Welcome all. Thank you so much for joining me here today. It's great to see you all are interested in searching in FHIR. So I hope you had an awesome time here at DevDays. And now for the last round of sessions, I wanted to focus a bit on the FHIR REST API with regard to searching. As this is a Let's Build session, I'm quite flexible. So first, I wanted to start with a quick introduction about what is searching, how do you do that in the FHIR REST API, do a basic introduction so that we are all on the same level. And afterwards, depending on your questions and interests, we could move over to some of the more advanced concepts about searching in FHIR. And I would like to do that through practical examples in Postman today. I've uploaded a PDF with some questionnaires and example search requests to the DevDays site. So if you go to the resources for that particular talk, then you can find a small quiz that you can try out now or at home. And it also includes some further links about the FHIR Search API. Before we get started, maybe a few words about me. My name is Zautke. I'm working for FHIR in Amsterdam. I'm one of the engineers on the FHIR server team. If you have any questions after DevDays about searching on FHIR, here's my email address. So just send me an email. I'm more than happy to help you out with any of your questions about searching in FHIR. So, why do we do searching in FHIR? Because you as a client developer want and need to have a quite flexible way of querying data from a FHIR server, because in the end we build through all of our resources a broad net of interconnected resources, and most oftenly you don't want to query information based on one particular resource type and find a specific instance based on solely the information that is given in a resource, but you query based on the relationships of these resources. So you search on some kind of information on patient or on observation and need to combine that somehow. So what we need in the end is an efficient way to traverse through the resources and find a certain set of resources based on, well, what we could maybe call filters. And in the end, you want to select an element, and we could combine that with a certain set of arguments, and together we do a matching based on these collection of filters. And that is what the FHIR Search API allows you to do. So, before we get into more details, one big red notice up here. So the FHIR search framework is really just meant for searching. It does not support any analytics use cases. So it does not have support for any kind of aggregation. So you can't query for the maximum value of a resource, minimum average, and so on. It has no support for subquerying. So you can't select a certain set of resources and then filter that set again. And it has only limited support for recursion. So if you have any requirement in that regard, you really should be careful of using the FHIR Search API. And in that case, I would recommend that you have a closer look on SQL on FHIR or CQL. If you had the chance of attending the talk from Google here at DevDays this week, then you know more about SQL and FHIR. If not, please have a look at the recordings of that talk. It was really great. And it will help you a lot more than the FHIR Search API. It's more like a preliminary search on the resources, and often you also need to do some kind of filtering on the client side to filter to the sets that you really want to have in the end, because there are some hard limits on the search API itself. But now, what can you do? First of all, every FHIR resource itself provides you with a list of FHIR search parameters at the end of the specification page of that particular resource. So, for example, here we have a subset of the search parameters on patient. And every FHIR search parameter is structured in the same way. We always have a name, a type, and a description, and an expression. So the expression is a FHIR pass expression. So you can see what the server is selecting if you do or try to achieve a match on that particular parameter with a given name. Now, how do you know what search parameters you could use? In that case, what we can do, now if we quickly switch over to Postman, every FHIR server is required to provide the search parameter that it supports in the capability statement. So, for example, if we select here the metadata statement, I just use the public vonk endpoint up here and search for the patient definition. Then you can see up here that there's also a section called search param in the capability statement itself. And it lists all the search parameters which are supported to be used as a selection filter on patient in that case. And it always, again, here, I can have then a closer look at the search parameter by, for example, also querying the ID of the search parameter. So if I know that, then I can also look it up directly. So let's see. For example, if I know the ID of the search parameter or the URL that I'm searching for, then I can, as a client, also dynamically look up the search parameter to say what the type is and also where the expression is is pointing to. So in the end here, we now again see that the metadata statement provides help to you as a client developer to figure out what the FHIR server is capable of, and you as a client developer can adopt your search query based on the capability statement. Now, if you see that a certain search parameter is not supported, then you can try to rearrange your query dynamically based on what the capability statement provides. Now, please note that not every FHIR search parameter needs to be implemented by a server. So it's only a list that where the FHIR specification says that it's likely that a client developer needs or has a certain use case to use that search parameter to filter the resources. But in every case, a server can reject a certain search parameter if it's not supported. And for that case, FHIR provides a way to communicate that, and that is through the self-link in a search bundle. So if we do a quick search request, for example, let's take patient, and we filter on a name, let's say Peter. Then at the end, in that case, of the bundle, I can find a self-link, and these self-links here include also the search parameters which are being applied to that particular search request. So if you're unsure if a certain search parameter was applied to your query, then you can always look up the self-link in a query and see if it has been actually applied to reduce the result set of your search. The reason for doing that is that you need to have a balance between performance of the indexing of the search parameter and convenience for you as a client developer. Because if you look at the number of search parameters in the FHIR specification, you will see that it's quite huge. And for every of these search parameter, you need to have an index ready in order to performantly search on that search parameter. And so the index can grow quite hugely. And so to give you a bit of flexibility here, FHIR says that you don't need to implement and leaves that up to the FHIR server. Now, if you would go through the FHIR specification and try to come up with an overview of the FHIR specification with regard to searching, you could come up with a diagram which would maybe roughly look like that. And you don't need to understand all the details right now, but what I'm trying to convey is that it's highly structured. First of all, we could come up with a category with regard to what kind of searches you can do, which would be either resource specific, so for example, a search to a patient, to an observation, or we could also do searches based on all resources. Then we have an abstraction system over the types of each search parameter has a certain type, which is an abstraction over the type system provided by FHIR. For example, all the specific types of FHIR when it comes to dates or instances or time are being abstracted away by a search parameter type called date. Because in the end, you don't want to be in the position of having to remember, okay, which exact element in a resource was of type instance or was of type time. With regard to searching, you only want to deal with a certain way. The same goes, for example, for token. And we have a more advanced area where we can filter resources based on references. So, for example, we have chaining, where you select a resource based on where references from that particular resource is pointing to, or reverse chaining, where you say, okay, I want to have all resources that point to a certain resource. So, let's start with the, yeah, please. That's different. Includes are for either including more resources that are referenced by a resource, or plus the one that are. Yeah, exactly. And underscore has, so reverse chaining is for selecting a resource which has a reference pointing to it. Yeah, exactly. So now first to the more limited use case. Was that a question? Okay, sorry. Limited use case where we only want to search on a particular resource. It has always a normalized structure where you say, okay, I want to do a GET request on a particular resource. I always use the name of the search parameter, and then I can provide the value which I want to filter on. So maybe we can try that out. So, for example, can you see that? Or I can make it a little bit bigger. Oh, is that fine? Let's see. Yeah, perfect. Okay. So, for example, here we have a procedure resource, and we want to select it based on a given date. And here we can see that we abstract away from the type system of the FHIR date provided in the resource itself, because the date in the FHIR search has a independent structure compared to what is in the resource itself. So the search date is always XML according to the XML specification. So, for example, if you would provide a time zone information, you would always use a T and then do +1 or whatever time zone you would be choosing, which would be different from what you would expect in, for example, on the JSON serialization of a date.
So by default, the standard of is it ISO standard? Like
Sorry, coming in?
So the standard that used to represent that date
Yep.
in our search parameter, is it like ISO standard?
Yeah, according to the XML specification, it's always an XML date. Yep. And if we go, for example, to the quantity dates, sorry, not dates, quantity elements, you can see that I can also provide the units of of the elements that I'm searching for, and can choose to normalize these quantities. So I can either select based on, in this example, on a kilogram, or I can choose to ask the server, okay, please find me also all observations which have a value quantity of 1,000 grams. And then we should get back the same results. Yep, please. Yep.
As you mentioned, like you are just in kilograms, right?
Hmm?
So, and let's say the source type is saved as a kilograms.
Yep.
But is there a way to do that same resource type by pounds? Would there be any, by some different measure, which is actually part of that subset, but
Yep.
data is not stored like that. Resource type is not stored exactly.
So in that case, the FHIR specification says that you should normalize according to the UCOM standard. The UCOM standard, it's a way to normalize these quantities. And if you can, if it's defined how you can transform the pound to a kilogram, then it should also be match the same resource. So every FHIR server needs to implement that, and there are different libraries who can support you in normalizing the quantities. But for example, there's also a web service where you can say, okay, I want to transform between pounds and kilogram or whatever units that you have. That's also provided as a service, but there are different libraries in JavaScript, in C#, Java, and so on.
Is everything you're showing part of the built-in search parameters that are allowed on the resource pages?
Yeah, exactly. Yep.
But if somebody wants to do additional ones,
they
can, right?
They can. So FHIR lets you define your own search parameters. because in the end, you just create a search parameter resource. FHIR itself defines that also as a search parameter resource. So there's no real difference between the one in the FHIR standard and that you choose to do as a custom resource. For example, you can use Forge to create custom search parameters. What you need to do is to fill in the name type and again a FHIR parse expression for the elements that you choose to. And then you need to supply that custom resource to your server. That highly depends on the server that you're using. For example, in Wonk, you can send that resource to the administration endpoint and do a re-indexing on that particular search parameter, and then it can also be used in the search request. Yep.
Some sort of search that is way more custom and complicated, would you maybe just turn that into an operation or something?
Well, it depends. So if you could express it, what you're trying to search on as a FHIR parse expression, and FHIR parse is highly powerful, then you can also include that in a custom search parameter. But if it gets too complex and you need to have some kind of more flexibility, then I would highly recommend that as a custom operation. What you can also choose to do, FHIR provides a _query parameter, which lets you define basically custom operations as part of a search. And you could even, in the implementation of _query, use other parameters which are also passed in the URL to pre-select a certain set of resources and then pass that to your query. Okay. Any questions so far on how to select values based on one resource? Okay. Now let's move over to how do I search on all resources? Because if you have a closer look at the FHIR specification, let me quickly open it up. You have here what we call the search param registry. And here you can see that some of the search parameters are shared between all resources, which would include elements which are shared by all of the resources. For example, the profile field or the tag field. Sorry, 1 second. And then you could use that to, for example, filter on a given tag of the resource which are provided to every resource in the metadata of a particular resource. For example, here I could say, I want to find all resources which are missing a particular tag, or any tag in that case, which is quite useful if you want to filter on resources which are, well, you could define a business rule where you want to say, okay, I need to have a tag on each resource, and here you could use it to find all the resources which do not have yet a tag. Yeah, please.
What's a good use case for that modifier source,
So in production, you could say, okay, maybe I have a tag for each source system where something is coming from. And then you could provide a certain tag to that. And say, okay, I now want to have every resource which is coming from that particular source system. Yeah, that's the most common use case that I have used tags for.
We use categories, so we've got a big server with lots of terminology resources in our case, and one client thinks it's sitting all with genomics one, so code system, like terminology resources don't have a category field, so we just tag them as a genomics resource. We make our own little tagging code system, and they tag them with that, and you can search based on the tag.
So anything where you want to categorize your resource based on some business logic, right?
Yeah, and where the resource doesn't already have a category, because some resources already have a category field and a search parameter for that category field, and that would be more appropriate for them. But for resources that don't, you need a tag.
Basically the same thing for profiles. So in some cases you can't require that you only accept resources with a profile, but maybe you want to at least know which resources don't have a conformance claim to it. So I could use _profile to select all the resources. Again, the missing part here is what we call a modifier. We get to modifiers later on. But here I would again see all the resources which do not have a resource a profile on it, or if I choose false, then I can see, okay, I only get resources which have a profile tag in the metadata. But and you also have different modifiers for these shared search parameters. For example, we have here the below modifier where I want to say, okay, I want to search for all profiles which are part of the HS7 namespace, which could be easily replaced by your own namespace and say, okay, I want to search for all the profiles which I provided to this server. So modifiers are basically a way to modify the default search behavior of a search parameter. And all of the resource types are, can be provided with a missing modifier to see if a element was provided, a value was provided for a certain element, or if it has at least a extension to that particular resource element. Because in FHIR, there is always a value or at least a extension on that element providing a value, at least a primitive extension to it. If not, the element is empty and we could use it to match with a missing modifier. Same for tokens. So tokens are also just an abstraction on the search API to find all elements which are somehow coded. So we would have code, coding, or codable concept. And in that case, often I don't know the particular code, but I maybe somehow know parts of the textual description of that code. So I could use that with a text modifier to use the text portion of the coded element. And also for, again, terminology, it's quite useful to have above and below modifiers to say in a hierarchical code system, okay, I want to match all the elements which are below a certain code in my code system. But again, there were talks this week which explain these in more detail. Most oftenly, really, in production, I've only seen the text modifier, and what is also quite useful, that you could use a not modifier to negate the meaning of the search request, which can only be done for tokens. That is a highly important limitation of the search framework. So you could not say, give me all patients where the name is not. That's not possible. So only for coded elements. So all observations which do not have a code, which is the following.
Or is there a way to search, like, because certain elements, right, in coding system may have different coding standards,
Yeah?
right? Coding standard may be different.
Mm?
So is there a way to say, okay, bring me the values where coding standard, is not this one, but the value, because here it's also.
Yeah, here you did
Can
provide the
you use without
system.
value? Can you
Yeah.
use without value?
Can you use the other kinds of tokens? So could you just say code not equals HTTP LOINC or
Yes.
pipe, which means anything that's
Non-line.
the LOINC system? The way that not would work?
Yeah, so you could leave out the last part.
Yeah.
You could not say, okay, I want to search, I do not want to search on this particular code.
Yeah.
So you can only leave the parts out that are come after, but not before.
There are three kinds of tokens. You can have both bits like that, which
Yep.
is I care about the system and I care about the code.
Or just system, right?
Or you can just put the system and then a pipe.
Which,
There's four types, sorry. You can put the system and then a pipe, which means I care about the system, I don't care about the code.
Okay.
Or you can just put the code,
Right.
which means I don't care about the system, but I do care about the code. Or you can put a pipe and then the code, which says there must be no system and I care about the
So
code.
when there is no system, it's going to be bland. It will be like code, not equal bland, pipe, then the.
Yeah, if there's no
That's
system,
all.
but that's rare. That's
Yeah,
very
it's
rare.
It's very
Yep.
rare. It's like doesn't make sense.
Yeah. Yeah.
But it's
That's,
possible, right?
yes, it's possible.
yep. Okay. So that's all about modifiers. Any questions to modifiers? Yeah,
I'll
please.
put in a vote for the in modifier. It's really cool.
Well, again, terminology, so it's highly optimized.
Sort of value set of codes that you're interested in. You can say subservice. You can say code : in, and then the value set URL, and it'll match against any resource where that search parameter code is in that value set.
But is there like subset of that value set if you have like, do you need to define it as a canonic URL so that you can search on that subset, right?
That's right.
Not the whole.
Yeah, and also we have not an, well, basically again a negation of that. By default, a string is based on fuzzy matching. So because we have all names with accent and all special characters, and you cannot expect a client to get that right. And in order to do that, it's expected from a FHIR server to search on a canonicalized version of a string. So strip out all the special characters, replace it with a normalized form of that character, and also strip out all of the accents.
But is there a possibility to have it start with, so the string, but start with?
By default, it starts with.
By default, it starts
Yeah.
with. Because you said fuzzy. Fuzzy means like it can be actual last 3 digits. Fuzzy is different than start with.
Yeah, fuzzy more in the way that you have a canonicalized version of the string. Yeah. Then for all of the quantities and dates, we can have prefixes, which are more or less self-explanatory. So you have equal, not equal, greater than, less than, and so on. Maybe the only interesting bit here is that you also have an approximately prefix, which again would do a more or less fuzzy searching based on the quantity. So a FHIR server can always include more search results where it expects that the result is interesting to the client, which goes also for all the other types. So if a FHIR server would say, okay, I do a string, I do an exact match, but maybe there is some character combination which I got wrong as a client, and I know or I expect that this also matches what the client intended to search on, then I can send that back in the search result. But in that case, I do not have a way to communicate that to a client because it would just show up as a normal search result. Yep. Please. Sorry? Okay. So, now to the more advanced concepts. So, we have a few highlights here. We have what we call chaining and reverse chaining, where I basically search on the relationship of the resources. And in that case, let's start with chaining. Here I say, okay, I start with what I expect to get back as a resource type. And afterwards, I build up the chain of where the connection of each resources are going. So, for example, I go from observation, which has a search parameter called context. From that, I link to a subject, in that case, a patient. And from the patient, I go to the general practitioner. And in the end, I supply the search parameter with the value for that particular search parameter, which is not a search parameter on observation, but actually on patient. So here at the end, I always have a search parameter which links to the resource type, which is basically the last in the chain.
But if you go to that example back, right?
Yep.
So,
So I want to search every observation which is somehow linked to a patient where the general practitioner reference is not missing. Yeah.
Because
Yeah.
underneath the text says it's missing.
But the important thing here is that general practitioner is a search parameter on patient and not on observation. So I can build up this change.
Yeah, you're right. The text is probably wrong in the last box.
Yeah, the text here explains that the patient is missing, the patient is not missing.
Oh, good catch. Thank you for that. Yeah.
So
Yep.
that's about filtering, not including.
Exactly.
Okay.
But you can use the same concept for includes. Also, we have reverse chaining, which is basically the opposite. So I want to get, here in that case, an encounter, which has an incoming reference from observation. And my common link between encounter and observation is the search parameter encounter. And here I can, again, search on a search parameter, which is defined then on observation. So this code is, I want to filter on an element in observation, in that particular case on that code, and then I see if it's somehow linked back to the encounter. And that would be equal to a ref include if I also want to include the observation back in my search result.
You retry every time the counter.
Yeah. So,
The result, the first result that you put.
so in reverse chaining, I only get the encounter, but as we have includes for also including the resources in my forward chain, I have ref includes, which include the resources which point back to that particular encounter. So here I only mandate that it has an incoming reference, but I do not get the observation included in my search result. But with the ref include, I can also get the observation pointing to it.
But include only the reference or
The complete resource.
complete result.
Yeah. in that case, the observation. Yeah.
So just
Oh,
quickly,
yeah.
so that code that you have coding, so that belongs to searching for that code inside observation, right?
Yeah. Yeah. And we have underscore type, which allows you to use common search parameters which are shared between each resource. So there are search parameters which are not only defined for all resources, but for a subset of resources. For example, we have condition, observation, and encounter, which all share the common element, a reference to patient. And if all of these resources that I supply to underscore type have all the same search parameter, then I can also use that to search on this expanded subset of resources.
And the search result of that would be a bundle with that source in it?
With condition, observation, and encounter, depending if it matches. Yeah. And okay, here what we already discussed, include, which is basically equivalent to the to chaining, and ref include to reverse chaining, if I wanted to include the resources that I have searched on. Last but not least, we have composition, a composite search parameter, which basically provides you a way of searching on two different values, but in a combined sense. So it has a different semantic meaning than providing both search parameters combined with an AND. So normally I would combine two search parameters with a logical AND, but they would be applied independently. So if I wanted to, for example, search on a group with a given characteristic and a value, and I would only search on characteristic independently of the value, I would get back all the groups which have a characteristic gender and a value diverse, but not necessarily would the value diverse need to point to the characteristic gender. But through a composite search parameter, which are defined for certain elements, I could combine them both, so I can only get back if this pair is present in the resource itself.
So is it like AND or It's all right?
No, that is a logical AND here. So both need to be present, but I can also apply a OR. So I would also search on the combination owner and Peter, as well as gender and diverse. That makes often sense if you want to combine a certain code with a quantity. So here I say I search on that particular line code given the combination with a quantity. But if I would apply them independently, I would get back all the resources which have a quantity which is greater than 80 kilograms, or that line code. But with the composite search parameter, I could combine them both. Yeah, and yeah, sir, come again. Yep.
When would you recommend to use regular searches in get operation versus there is a search for post, when you do a post operation?
Well, normally you would just use the get request because it's more commonly used, but in some situations you can't do a get request. And then you could also do the same search with a post. Some servers block get requests, depending on your configuration with reverse proxies in front of it, or form posts where you have a form on a website that you need to send to the server and you really want to use post, then you can do it with underscore search as well.
The technical is a really big request, the get size
Yeah.
is actually limited. So if you've got a really request,
Yeah.
sometimes you have to post it. I've seen it.
I think the original use case for it was that many proxies log the URL, but not always the body.
Yep. Here I included some of the talks which are touching also on the subject. So for example, the talk from Hard Samurai on SQL and FHIR, or from Google. So if you have time at home, please have a look at these, because sometimes you cannot solve everything with the FHIR search, and these methods help you to extend the limitations of the FHIR search API. Yeah, and with that, thank you so much.